Good morning and good afternoon, everybody, and welcome to our third Hangout for National Science and Engineering Week in the UK. We're here to celebrate science, maths, engineering, and technology, and also to tell you a little bit about the Google Science Fair. And there are 2 weeks left for young scientists around the world to apply to that. We'll tell you a bit more about that later. Right now, I would like to start with some introductions. My name is Tia Lendo, and I'm on the Google Science Fair team, and I am calling in from New York this morning, so it's a little bit early. It's first thing, and we have guests who've joined us from around the world to take part in this Science Fair Google Plus Hangout. Today, we're joined by the group, the Festival of the Spoken Nerd. Now, this is a comedy group made up of scientists and mathematicians, so you're going to hear today a look at some very interesting questions in science and maths, told by comedians and musicians who actually studied the subjects themselves at university. So I want to get started with some introductions here. Let's start with my colleague who's joining from London. So Ange, if you want to introduce yourself.
Hi everybody, I'm afraid there's a bit of a fire alarm going on in the background, but I'm Angela and I'm calling from Google London today. I'm really excited about today's Hangout.
It just shows that it is in fact a live Hangout on air, that she's actually got. Well, we're joined by two schools this morning. Let's start with the Thomas Hardy School. If you all could introduce yourselves.
Hello, we're Thomas Hardy School in Dorchester, Dorset, and these are some of my best Year 9 students. Mrs. Aberdeen.
Welcome. Thank you so much for joining, particularly I think on your lunch. We really appreciate giving that time out.
No problem.
Excellent. Okay, and then I think we also have Mr. Gilbride's class.
There we go. Hello. This is some of the best Year 10 students that we've had. In fact, the best Year 10 students we had at FOTSN School in Woolwich in South East London. So, hello.
Great. And if you can make sure that as you're asking your questions today, you're nice and close to the microphone. That was Mr. Gilbride with some of his girls from Plumstead Manor School for Girls in London. Thank you so much for joining. And then we have the members themselves, the members of the Festival of the Spoken Nerd. So let's start off with Steve and Helen. Where are you calling in from today?
Hello.
Hello there.
This morning we are actually live from the Cambridge Science Festival. Woo! Which is an immense science festival run by the University of Cambridge. We're doing a few shows this weekend, and we've taken over their office.
Yeah, this is the admin office. They're all exhausted, but they're pleased to have us here.
Well, they're getting treated to a free science and math show, so I'm sure they're very excited. But thanks to them for helping support this. Okay, and then I think we've got our furthest traveled, if you can be virtually furthest traveled, and that is Matt. Where are you coming from today?
I'm in Perth in Australia, so it's late in the evening over here, but I'm still predominantly awake, so we should be all right.
Please
I'm
stay
coming
with us.
live from the Just Me Science Festival, which is just me in my room. This is my admin as well, by the way, just the blackboard and me. This is my support staff. Yeah.
What is that, Matt? What is that?
It's a blackboard.
What?
Oh. I haven't seen one of those for years.
I know. I've got a special stylus that I use to interact with the whiteboard. If you want to change the picture, you can go from the blank one. If you do a swipe action, you get a picture of a line.
How do you undo? How do you undo? Is there an undo
I have undo. You need a different one. I call it paper towel. And the undo, it's more of an up and down action. So
Okay.
This is the undo. And we're
Wow.
That's very impressive.
That is something.
It's frozen.
It's only the best in technology here this week for National Science and Engineering Week. Sometimes there's old standbys. Excellent. Well, we might have another student joining us, Oluwasegun, but I know he's having a bit of trouble with his internet connection, so we'll hope that he does join. And I know we have many other people who are watching the live stream. So if you are watching the live stream of this Hangout on Google+, please do ask your questions by writing in the comments section. Our colleague Angela is going to be monitoring that throughout, and we will take a few of the questions from the live stream. So I really encourage you, please, to throw your toughest questions at Helen and Steve and Matt today. Now, the way we're going to work this is we're going to take a look at a few interesting science and maths questions. So we're going to start off with Steve. Steve does science experiments on the popular kids show the BBC Kids show Blue Peter, which many of you who live in the UK will certainly know. And he has a master's in physics from Oxford. So we're going to let Steve kick it off. He's going to do a short presentation, and then we are going to turn over to some of your questions. So Steve, over to you.
So yeah, I studied physics at university, but this is something I got interested in. I got interested in polymers. Polymers is actually chemistry. Polymers are amazing molecules, and I've never had any kind of science fairs or anything like that growing up, but this is the sort of thing that I would get into and probably do at a science fair if I'd had the opportunity, because it's all stuff that's kind of around the house and stuff that you can build, and I love kind of building stuff and exploring stuff, and polymers are a great thing to explore because they're amazing. They're basically like really, really long molecules, and so I've got like a model here of a polymer molecule. You see, like it's a chain of beads basically, and if you imagine that each one of those beads is like a small molecule, and you chain like tens of thousands of them together, then that's the kind of size of a polymer molecule. And when you've got something that long, it can behave in a really weird way. And so I want to show you, hopefully this will come across on the camera, like a weird way that this polymer chain behaves. Let's see, I'm going to tilt the screen up. There we go. Okay, here we go. So can you see that? So yeah, so that's it. When you've got something really long, like a polymer, it can behave in weird ways, and there are real kind of molecular polymers that behave like that as well, like self-siphoning polymers, like polyethylene oxide. I haven't got time to show you that, but I'm going to show you one of my favourite polymers, which is this one here. This is called sodium polyacrylate, and it's a superabsorbent polymer, and it's in a powder form at the moment. It's called a superabsorbent polymer because it can absorb like 300 times its own weight in water. It's the stuff that makes nappies work, but it's really cool in this form.
And for our guests who are in the U.S., nappies are...
diapers, sorry, diapers.
Diapers.
Okay. Okay, so let's see. And all I have to do is add hot water, and hopefully this will be pretty cool. We'll see how it goes. Isn't that cool? It just keeps coming and coming like that. And so you can use this on, like, you know, Christmas decorations and stuff like that.
You're just totally messing up their office there, aren't you?
Oh, yeah. So what I've done is put down a bin liner. Or trash bag for our friends in the US. Look at that. Isn't that amazing how much is created just from that tiny amount? Okay.
Oh my God.
Okay. So, but the way sodium polyacrylate works is incredible. So it's the sodium that's important. Does anyone know the chemical formula for salt? Go shout out, you know. So, NaCl, exactly. So sodium chloride. So salt has got sodium in it as well, sodium chloride. And when you put salt in water and it dissolves, what's happening is the sodium and the chlorine are separating, and the sodium is taking a positive charge and the chlorine is taking a negative charge. And the same thing happens with sodium polyacrylate. When you put it in water, the sodium kind of swims off. It swims away, taking a positive charge with it, leaving that polyacrylate chain with a negative charge, right? And so I want to show you what happens when you give a polymer chain a negative charge. And I've got another sort of physics demo to explain what happens when you do that. Okay, so I've got these sort of, let's see, I don't know if you can see, okay, so these are like sort of thin strands, and imagine these are the polyacrylate chains. Imagine these are the other chains, and I'm going to give them a negative charge. I've got this thing, it's called a static wand. It's called a fun fly stick if you want to buy it, and I can use that to give these strands a negative charge. So here we go. See if you can see this. Can you see that? Is that on camera?
Yes.
Okay. So you can see that, so like charges repel, right? So the negative charged, okay, there you go.
Your lovely assistant.
Okay. So anyway, what was going on there was all those negatively charged strands were repelling each other because negative charges repel other negative charges. So they were moving as far away from each other as they could get, creating all this space in the middle. And it's that space in the middle that turns sodium polyacrylate into this incredible sort of super absorbent molecular sponge. And so that is my bit about polymers. And yeah, any questions?
All right, let's see who has some questions about that. There was a lot of magic stuff happening there. Students, any questions about what you were seeing?
How does the powder get put in the napkin? Or diapers?
Yeah, so when you if you get a nappy and open it up, you'll see there's loads of kind of spongy foam in there, but also like sprinkled in is that powdery stuff, and and there's not much of it at all. Like if you shake it all out onto a table or something and gather it all up, you'll only have like half a teaspoon of it or something actually inside a nappy. So you can, if you want, you can actually look inside a nappy and find it, and it'll be like these little grains. And yeah, try adding water to it, and it'll expand. It's pretty good fun to play with, actually. Yeah.
But if there was loads in there, like the baby would kind of go.
Yeah, exactly. You don't want to put too much in that. Yeah. Especially if yeah, exactly. If the baby was drinking too much and weeing too much, dragging around a nappy.
What else? Any questions from Thomas Hardy there?
Can you keep making more and more? So once you've like added water to a bit and then it creates more, can you add more water to that and it makes even more than that?
So it expands to, it'll absorb about 300 times its own weight, and then beyond that it stops. Actually, the interesting thing, yeah, is that it absorbs so much water that it starts to take on some of the physical properties of water, like refractive index. I don't know if you heard of refractive index, but so like if you look at this, I don't know if you can see, it just looks like a jug of water. But actually, inside this jug of water is hidden some sodium polyacrylate beads, and I should be able to show you that if I just pour out the water. I'm making such a mess.
Oh.
You see all those beads in there?
Yeah. Oh, yeah.
I don't know, let me get some out.
Wow.
And so the reason they were hidden is because they've got the same optical properties as water, so light just passes from the water through the bead and then out the other end without being sort of bent, you know, so there's nothing bending the light around. So it's pretty cool stuff.
Wow.
I don't know if anyone wears one a day contact lenses, the kind of really floppy contact lenses. They're made of the same stuff, so that when you leave them out on the side and they go crinkly, it's because all the water inside them is evaporating away.
Cool.
Thank you.
Is there anything else that is similar in the amount of water that it can take on, or is that kind of one of the top materials for that?
This is one of the top materials, and it was originally developed by the American government back in I forget when it was now, but so people have developed kind of more high-tech stuff as well, like oil-absorbent polymers. This is a water-absorbing polymer, but there's oil-absorbing polymers, and if they can get the price down, they could be used to clean up oil spills and stuff like that. So there's loads of cool stuff.
Excellent.
We have one more question, if that's okay.
Yeah.
Yeah, please.
Yeah. Ian, go on.
Are there any disadvantages to using the sodium?
Sodium polyacrylate. Not really. I mean, it's not toxic or anything like that. So, like, it's not bad for a baby for it to be in their nappy or diaper. And also, like, you can reuse it. So if you dry it out, it'll go back to that kind of granular form, and you can reuse it. So you can use it to like dry out clothes and stuff like that. I don't know if you've ever bought something like electronic equipment or something like that, and there's a little sachet inside that keeps everything dry. That's made of the same stuff as well. So there's loads of uses for it, and it's not toxic. So I don't think there's really any downsides at all.
Great. Cool. Well, thank you very much. We can definitely have more questions for Steve later as well. But let's move on to Helen. Helen is a physics graduate from Imperial College in London, and she now writes funny songs about science, including for BBC Radio, and does a number of live performances, like she will do today. So over to Helen.
Absolutely. So how many of you like space? Well, that's what got me interested in physics. That's one of the things I really love about physics is that you don't need loads of equipment, you don't need loads of expensive stuff. You can just look at the sky and you can find out so much about physics. And one thing that I used to be really obsessed about was what the sun looks like. And what is it like on the surface of the sun? That's one of the things that got me really excited about science. And I've actually found some pictures from the NASA website. I'm going to try and share them with you now. Have a look at these. These are pictures of our sun. Look at that one. Can you guys see that?
Yes.
All right. That is a picture of the sun. The colors are a bit different because it's been put through loads of filters. But can you see this bit on the right-hand side of it? It looks like something exploding out of it.
Yeah.
That is something called a coronal mass ejection, which is a little bit like the sun just doing this. So some of the inside of the sun explodes out in this big jet of all the plasma and all the gas that's inside it. And these are amazing, these coronal mass ejections. And if you look on the NASA website, there are loads of pictures of them. That's from June 2011. This is another one of a big coronal mass ejection from January of this year. Then there was another even bigger one recently. And you can see all the colors are all crazy, but you can see there's something wild going on there. That's coronal mass ejection. Because the sun is fascinating to me, and it's incredibly hot. It's 1.4 million kilometers wide. It's this ball of superheated gas. It's like a nuclear fusion machine. So every second it turns 600 million tons of hydrogen into helium. That's how it gets its energy. But it's not, you can see from those pictures, it doesn't always look the same. It's got its own kind of character of its own. It's not just a big ball of burning gas. And that's something I find really interesting. And I write songs about science, and I wanted to write a song. And this is maybe something that you might be interested in doing, kind of looking at the scientific facts and putting them in and this is what I love doing. I love taking science and putting it into a context that no one's really done before, and that's what I've tried to do in the sun, in a song about the sun. Because I wanted to make a little story about this, because the sun is not the same all the time. At the moment, we are about to go into a period of really high activity on the surface of the sun. So over the next couple of years, we're going to expect a lot more of these amazing coronal mass ejections. The NASA website is going to have pictures even more often of these incredible things happening on the surface of the sun. And I've spoken to solar scientists, and they've told me that this is perfectly normal. This is what the sun does. About every 11 years, it gets really active, and then it drops down in activity, and then 11 years later, it's really active, and then it drops down again. And I thought, well, that is the truth. That's what scientists have discovered has happened. But what if the sun was a human being? And what if the sun had a different way of looking at things? And what if we didn't have science? The only thing that we might guess about the sun is that the sun is upset about something. This is what people used to think before we had science to work out the reality. So I've written a bit of a song where I've imagined that it's nothing to do with the normal cycles of the sun. It's just the fact that the sun has got his hat on. I used to be someone, now I'm just another sun. one of 100,000 billion. You treat me insignificantly. Name a tabloid after me. Synonymous with paparazzi, just a backdrop of Brian Cox on TV. Since Edwin Hubble, it's never been the same. Those pictures of other stars push me out the frame. You never even gave me a proper name, like Alpha Centauri or Epsilon Tauri or Delta Libre or HR2948 or Kevin. You've achieved nuclear fusion, oh well done. Made some helium from a little hydrogen down there on Earth. Every second I do that to 600 million times. If I was Marilyn Monroe, you'd be Stacey Solomon. You should have stopped at Copernicus. Then I'd still be the center of your universe. You say I'm just an average ball of gas. I say you're talking out of Uranus. I'm not sure that's how it's pronounced, but we'll just go with it. 1.4 million kilometers. That's my diameter. Tell me seriously with those parameters, have you ever tried to put a hat on there? Hip, 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 hooray. Well, I'll be a red giant someday, and your world will go up in flames. But in the meantime, please join my Facebook fan page. Facebook.com/thesun. That's the way to get around the world of science, is to do a song about it. Thank you very much. I enjoyed doing that for you.
Brilliant. And it's very fitting that Angela would join us back, having not burned up, like on the face of the sun.
No, I have just escaped the building though.
Are you in a coffee shop now? It's amazing.
Yeah, my friendly local cafe, yeah.
Wonderful. Fabulous. All right, so Helen was singing about the sun. Who has some questions for her? Yeah, go ahead. Plumstead Manor. Sure.
What makes the sun have the coronal mass ejection?
Sorry, what?
What makes the sun have the coronal mass ejection?
Well, now, this is where I have, the song that I wrote, I got it checked out by a solar physicist who's someone who knows a lot more than me about the sun. And the things I understand about the sun with the coronal mass ejections is because the whole of the sun, which is my warning that I might get some of this wrong, and you should check it out properly. And the whole of the sun is like a big ball of superheated gas. So when it's called plasma. It basically means that everything is so close together and so hot and all jumbled up that it doesn't react like any kind of material on Earth. It's like a huge ball of gas, but sometimes it acts like a liquid as well. So inside this big ball of gas, you've got kind of currents like you have in a sea or in a swimming pool, and it's all the movement of this gas spinning around. It's got magnetic fields as well. It's got little patches called sunspots, which scientists are still investigating because they still don't totally understand what they are. And it's all of this movement and activity that causes the huge coronal mass ejections. Huge amounts of material gets blown out from the surface of the sun. The sun is, although it's our nearest star, there's still a lot to be learnt about it. And that's why there's so many amazing pictures being taken of it at the moment. Those pictures I showed you a minute ago, they're taken by Stereo, which is these two satellites flying really close to the sun, and they take basically 3D pictures of the sun. You go on the NASA website, they've made some films out of those pictures as well, so you can watch these sunspots exploding out of you. It's absolutely incredible. Does that answer your question? It's a difficult thing. It's like nothing else on Earth.
I don't think scientists know the full answer to why coronal mass ejections happen, but it is something to do with the fact that it's a plasma, and that means that they've got these magnetic fields and all that sort of flowing around. But yes, I don't think anyone really fully understands.
Yeah, and we can't get close.
Actually, if I can chip in on the magnetic fields.
Yep.
What the research is at the moment is the way the sun moves, the magnetic fields get very tangled. And so you get developing what's called a flux rope, which is a big tangled tube of magnetic field lines. And what we don't fully understand is exactly what causes it to rupture, but basically that field line reconnects and erupts and shoots both plasma and magnetic field out towards us. Well, eventually.
Matt, where do you get your solar information from?
Well, I've gone to the lengths of acquiring a solar physicist as a girlfriend, and that means I've had to listen to the reading around the subject.
Yeah.
So,
I mean...
You've got a girlfriend?
Yeah,
No way.
he does.
Yeah, it's non-fictitious. It's amazing.
She's the one who did all the fact-checking on my song, so
Yeah.
the Open University have approved it as a learning tool. But I think that's a fantastic question, because you've asked a question that actually science doesn't know the answer to. That's exactly the kind of question that scientists are asking right now.
Mm.
That's my excuse for why I don't have an answer.
Any questions from Thomas Hardy School?
Why did you choose the sun out of all the other planets? Does it interest you the most?
Well, why did I choose the sun rather than anything else?
Yeah.
Well, because I do think it's our closest star, and it's the one that we have the most chance of finding out about in real detail. Because our nearest star that is anything like the sun is hundreds of thousands of light years away. And if we look at our sun, which is the closest star, because the sun is different from any other planet in our solar system. All the other planets are solid material, or they're balls of gas that are quite stable. But the sun is like a nuclear fusion machine. It's a huge ball of exploding gas. I mean, it's incredible. And it's the closest star to us. So if we understand about the sun, because we've got quite a good chance of understanding about it because it's so close, then we can learn a lot of things about the rest of the universe, because we can guess that some of the other stars are a bit like it. Maybe they do different things. We can learn more about the universe that way. It's like having a celebrity on your doorstep. This sun, it's so close to us. It's possible to find so much about it. But that's why I got really frustrated, because so many people spend all their time looking at, you know, the stars up in the heavens and the distant stars. And I thought maybe the sun might get a bit upset about everyone looking at pictures from the Hubble Space Telescope when the sun is sitting there waiting to be looked at. So I don't know, I give the sun a personality. It seems like it needed one.
Excellent. So Helen, one question here is, you know, how do the scientists know that there's about to be a period of a lot of activity? How would they figure that out?
Yeah, because it's a really regular thing. About every 11 years, it's a cycle of about 11 years where the sun becomes very active, and then it drops down, and then it becomes very active again, and it drops down. And by active, it means there's more coronal mass ejections, there are more sunspots, there's more activity, there's more of this solar wind coming towards us, which is something that we have to be careful about, because it can interrupt electrical devices, it could interrupt how satellites work. So sort of the reason we know we're about to go into a period of activity is because we've been observing it for hundreds and hundreds of years. So there's this 11-year cycle of ups and downs in the sun. And then Steve, you were telling me this morning, there's also about a month-long cycle as well, where it gets more and less active about once a month. So there's all these cycles, and all of it is because we've observed the sun so closely for so long. We can't predict where the sunspots are appearing or when a coronal mass ejection will happen, but you can know quite easily when it's more likely to happen.
The last time a coronal mass ejection caused real problems on Earth was in 1989, and it was in Quebec in Canada, and it caused the power to go out. So they had a blackout of power for hours and hours in Quebec. because of all this stuff heading towards Earth, bringing this strong magnetic field with it, interfering with the Earth's magnetic field, and causing these currents to run through the ground and knock out the power. It is something we need to worry about, really.
Yeah, but I mean, the Earth is tiny compared to the Sun, so we're really far away. So we're like a tiny pinprick in the radius of the Sun. So not many of the coronal mass ejections even come close to where the Earth is. But every so often, one of them will.
We are going to move on now to Matt Parker, and then we will take a lot more questions at the end, all three. So Matt Parker is a maths graduate. He's also an ex-teacher and was a finalist in the science communication competition, FameLab. He's the UK's only mathematician stand-up, or I should say stand-up mathematician, we believe. And he writes about math for The Guardian and for The Telegraph. So I'll ask everybody else to go on mute while we hear from Matt.
Now you've seen Steve showed you some of his favorite chemicals and various polymers, and Helen sung about her favorite object in the sky. I'm going to show you one of my favorite shapes, and you can make one of these afterwards. I have here a square of cardboard. The square is not my favorite shape, it's okay. I'm going to use this square to make my favorite shape, and if you get bored afterwards, you can make one of these. Ideally, you'd make this just with a normal piece of paper. So take your favorite ratio of paper, either the wonderful A4 paper in the √2 ratio, or whatever it is they use in America, and cut off however you wish the extra bit of paper and get yourself a square. And as you can see here, I folded my square into a square number of smaller squares. I like squares. So I folded it in half, and then in half again one way, and then in half again the other way, and I've made it all quite flexible. And then on one that I, of course, prepared earlier, I have cut the middle square out of the bigger square. And I'm going to use this square of squares to make my all-time favorite shape. And so here's what you do. You take your square of squares, and you start with the left-hand side, and you can take these 4 squares, and you can fold them over on top. You can then take the top, what is now 3, but obviously one's folded over, and you can fold that down. You can then take the right-hand one, because I'm working around the square, fold that in. And at the bottom one, when I fold that up, I want this to be a wonderful symmetrical shape. So I want to fold this up as if it was before I folded this one over. So I'm going to move that first one out of the way, then I'm going to fold this one up, and then push this through underneath. And this is the bit where it all goes horribly wrong, but that should, there it goes, poke under there. And this, where it looks like a square, which is of course not a bad thing, this is one of my all-time favorite shapes. And I'm going to show you very quickly why this is such a brilliant shape. And to do that, I'm going to number my squares. So on the front, I'm going to give them all a 1. So these are all the 1s. And on the back side, number 2, I'm going to give them all a 2. So there you are. So I've got 2s on one side, so you can see those there. If you turn it over, I've got 1s on the other side. Do you remember what was on the back of the 1s? Well, it's a blank, actually. This is the 3rd side. I'm going to label that with some 3s. Okay, so that makes sense. I've got 3s on that side. I've got 1s on that side. On the back of the 1s, I've got 2s, and then on the back of the, what was behind the oh, it's blank. Okay, so it's blank and 2s. So I'm going to label those as the 4th side. Okay, so this is now side 4. And this shape, as you can see, depending, oh, that's terrible. Bear with me, that's a 4. This shape, depending on how you turn it over, will have a different numbered side. So we've got the 1s and the 2s. And if you fold it one way and open it up the other, you'll have 3s on the back. And if you fold that down one way, open it up the other, oops, I've got lost, open up that way, I'm back to 1s and 2s. In fact, there are 6 different sides in there. So I found another blank one. I could label that as 5. There is a 6th one in there. If you want to make these, this is called a flexagon. And I didn't bring the blackboard for no reason. If you want to look it up, it's called a flex, because it flexagon. And so this particular flexagon starts as a square, and so it's called a tetraflexagon because it's got 4 edges around the outside, and it's got 6 faces if you're very careful. So we call it the hexatetraflexagon. And so you can find instructions for this online. So in fact, maybe tonight, if you're bored, get lots of paper and some scissors. Maybe invite some friends over, right? Have a maths party. And at your maths party, you can make lots of these. This is a hexatetraflexagon. There are other ones as well. So there is a hexaflexagon, which is shaped like a hexagon, but it flexes. And you can make, there's a tri-hexaflexagon, which has 3 different faces. And then there's a hexaflexagon, which has 6 different faces that you can flick between. So there you are, the flexagon, one of my all-time favorite shapes. Thank you.
Very cool. Everybody can go off mute now. I think we sorted the audio. I do think
it was nice talking about the flexagon to deathly silence. That was
that
lovely.
shape is worth of some applause. I think. We just got the echo back again. I'm not sure if it was Helen. Maybe you can try to mute. We'll see. Any questions about the flexagon or other shapes for math?
I'm getting a bit of echo on my blackboard here. If anyone else has a blackboard on, could you turn it right down, please, so it doesn't get the... Forget it.
There must not have been Helen and Steve. Any questions? Yes, Plumstead Manor, please.
Could that possibly be made into a cube?
Oh, could that be made into a cube? It probably could, but just like this is a flat 2-dimensional shape. So you can see, well, obviously it's made of physical paper. Damn you, physical reality. Strictly speaking, there should be a 2D shape, and then you lift it into 3D to then flex it over. So I suspect you could design a 3D flexagon, but you need to fold it over in 4D. And there's no reason why you couldn't do it. There is a reason why you couldn't physically do it. But mathematically, you could possibly design that, because there are a lot of very cool 4D shapes that people have designed which only work in 4D. But mathematically, we can investigate them, but just physically, you can't build them.
And I'll just pause us for a moment. I'm hoping that we can sort out this echo. So if everybody else could go on mute again. It's someone's machine is echoing quite a lot.
Do you want me to mute as well?
Well, Matt, I don't know. You had it sorted earlier, but then it did just come back. Okay. Other questions for Matt? Any questions from Thomas Hardy? Oh, Helen's got a question. All right, Helen, what's your question?
My question is there any practical use for this whatsoever?
Practical use? Forget it. I'm out of here. No, there's not. There is some practical use behind. Well, it's a cool, awesome toy. There you are. And what else are you going to do at your maths party? No, there is some practical use for these shapes, but it's not the actual shape. It's the maths that you learn from the shape. So if you do make one of these, or any of the flexagons, you can start to look at what sides pair up. So you can see side 1 pairs with side 2, and so I could label it here. I'm going to put, okay, 1 and 2 go together, and then if I flex that, I get 2 and 4, and that means I can link this to the combination 2, 4, and then I could see that this links to the combination, let's say 3, 4, and this might link over here to 1, 5, and you can actually build up the entire network of all the various combinations, and you can find that there are cycles you can go around, and in maths we call this the graph of all the various face combinations. For some strange reason, once you leave school, what you used to call a network, you now call a graph, and what you used to call a graph, you now call a plot or a chart. And so basically there's an area of maths called graph theory, which is about looking at networks and investigating how they behave, and that is very useful behind building robust computer networks and modeling interactions of different organisms and other sorts of, I believe, real-world applications. But to be honest, it's all about the awesome shape. Let's be honest here.
Didn't you? Isn't there a beer mat that you can make with a Flexagon that's quite useful?
Yes, I may have designed a beer mat. I designed a. This is a school's talk, Stephen. No, I designed the Hexaflexagon beer mat, and so you fold it different ways, and it tells you what drink you've got or whose round it is, and so there's 6 different faces on the beer. Because, frankly, I mean, how
well,
many
if everyone's having cola, it's fine.
Exactly. If you've had lots and lots of Coca-Cola, a Flexagon really messes with you. Actually, if you want to build the Hexaflexagon, I have got instructions, and there are loads of instructions and videos online. So I will put a link up somewhere for the instructions to build the more complicated versions of this.
Excellent. We'll make sure that we put the links out for people who want to build that shape at home on the Google Science Fair page, and I'm sure you'll put it on the Festival of the Spoken Nerd site as well. Now, I don't know if do we have time for one more segment, Matt, or should we go to some more questions?
I've got a question, sorry, before
Oh,
we
yeah,
go,
great. Thomas Hardy School, please.
Sorry. You said people design these. How do you go about to design one? Where do you start from? Do you start from the graph, or do you start from somewhere else? How do you put it on the paper?
That's a very good question. So how you go about designing one of these ridiculous shapes? The very first one was built by accident. So a British mathematician was working in America, and he got the ridiculous, what's the American paper? It's full scrap? I forget. It's one of the drop-down options when you print something on a computer. And it's a different ratio to the English A4 paper. And so he had to cut little strips off the edge to get the paper to fit into his old file, because he had the English file. And he was just folding these little strips of paper into triangles, and he accidentally built the Hexaflexagon. And went, oh, this is amazing. And then other people got involved and started to look at the maths and the graphs, and there's various paths and things you can do to navigate your way around the shapes. And it was very much just from playing with the fun side of folding bits of paper that people discovered them, and then after that discovered the maths.
Oh, cool.
Cool.
So tonight, when you're all having your maths party, it's a Friday night after all, I do recommend starting with the Hexaflexagon. I can see you touching your head, guy in the front row. All right, this is a two-way video.
You don't have to go to the stage to do it then.
I missed that.
Okay, so Helen, did we have time for one more thing, or should we just go for a few more questions? Oh, you're on mute, Helen. Helen, do we have time for the one more experiment you were going to try, or should we just finish off with
questions? Yeah, questions about
with maps. I wasn't sure if he was going to try that next one. Okay.
No, I think
perfect.
We are preserving the Cambridge Science Festival's office by not flooding it.
That's like a great idea. Perfect. Okay. So, any other questions for the three of you? I've got one, and then maybe if any of the students have a few more. I guess to each of you, how did you get into this sort of work? It's very unusual, so I'd love to hear.
Who wants to go first?
I guess that's you, Steve.
Okay.
Yep.
I mean, I love science because I just like knowing how the world works. I've always been inquisitive, and I think understanding how the universe works is it's not just important. It's just, I don't know. I just think it's a really fun thing to like explore how everything works, and science is the best way of understanding how the world works and how we work and all that sort of stuff. I really like stand-up comedy, and I started doing stand-up at university, and it was like the most nerve-wracking thing I've ever done. Like, couldn't sleep for a week before it happened. But it was really, I really enjoyed it, and I ended up doing it when I moved to London, and that was really scary because Londoners that go to comedy clubs aren't that forgiving, and
not that into science.
No, exactly, not that into science. So, and so I did that for years, and then in 2007 I got the opportunity to combine the two in something called FameLab, which is a UK one, it's now Europe-wide actually competition to find science communicators, and so I managed to combine the two, and I've been doing it ever since, just because it's so much fun.
What about you, Helen?
Yeah. Well, I came from a it's fairly similar route. I studied physics, and then I left science completely. I always wanted to be able to do science and arts at the same time. I wanted to do science and music, but the problem is you often have to make a choice. So when I went to university, I decided to do physics instead of music, and I had to make that choice. And then when I left university, I went back to do music for about 10 years. I worked for a BBC radio music station. And then I started doing stand-up, and it's actually stand-up that got me back into science again, because I started doing gigs with people like Steve and Matt and people like Robin Ince, who instead of just telling jokes, they were talking about things they were passionate about. And I realized that I was really passionate about science, but I hadn't thought about it for about 8 years. And then suddenly it all kind of flooded back at me, and I now am doing exactly what I always wanted to do when I was young, which is mix science with music. But I never thought that was possible, and no one ever told me it was, so I've had to spend 10 years working out how to do it.
Well, and I remember, correct me if I'm wrong, Helen, but you, while you were at Imperial, spent a lot of time at the Royal Albert Hall, which is, for anyone who doesn't know London, an amazing music venue, and I think ended up studying some of the physics of the actual venue itself.
That's the only way I could combine music and science is by studying acoustics, but I wanted to do something performing as well, so the scope is very limited. I'm in a very small pool of people, I think of one musical ukulele playing physicist. I'm the best, though. I mean,
and the worst.
And the worst, yeah. I'm the best. I'm the sort of halfway down the chart, and I am the worst ukulele playing musical physicist.
Thank you. And Matt, what about you? How did you get to be a maths stand-up?
Math teaching. So when I went to university originally, I actually, and this is strictly confidential, I just between us and everyone watching it on YouTube, I originally did mechanical engineering at university, because I love engineering, and I got about halfway through a mechanical engineering degree before I realized I'd be dangerously employable by the end of it, and so I got out. And thankfully I'd been doing physics at the same time, so I went over into the physics department, and I still to this day absolutely love physics, and not just because my girlfriend is a physicist. And so I actually, during my physics degree, as much as I loved it, I realized that I was just a closet mathematician, and so I was just happiest when the equations worked out nicely. And so then I went into the maths department and got my maths degree. And when you are at university, as long as you're studying what you enjoy, you will get through. And obviously you can be very flexible as you go along. So I kind of meandered my way through university before stumbling into what I absolutely loved. And along the way, I was doing other things, like I was writing for the student paper, I was making short films with the short film people and doing bits of comedy on the side, which was endless fun. I got to the end of my maths degree and went, right, now what? And so I decided to become a maths teacher, because it's just one non-stop maths party. So I, throwing up the parallel vectors there. So I went into maths teaching, and I taught maths actually here in Perth, where I'm visiting family. I'm doing some performances in Australia at the moment. And then I decided there weren't enough people throwing chairs at me, so I went and taught in London for a while. And then I gradually drifted into, because I started doing stand-up on the side, much like the other guys. I started to combine what I do with stand-up, because how else was I going to get roomfuls of people to listen to me talk about maths? And so now, just like Helen mentioned, the two halves of my career, so the serious math side, I'm miming a Venn diagram now. I could draw it. No, it's okay. The serious math side and the comedy side are getting closer and closer, and I absolutely love it when I'm in the intersection of that. I can do comedy while talking about maths, because maths is great.
Thank you. I'm not surprised to hear all of you talk about, the fact that it was just your passions and things that you loved, You know, we had a hangout with will.i.am last week from the Black Eyed Peas, and we had a hangout earlier this week with some university students who loved Legos and ended up using Legos in their research, so they get to kind of play with toys all day long. And, you know, the thing in common is that people are just, you know, pursuing what they love. And certainly all 15 of our finalists last year for the Google Science Fair just talked about that, you know, when they were picking their science projects in school and for the competition, they just picked a question that they loved, they were really curious about. That was absolutely in common about all of them. And so any of you who are here with us today, either at Plumstead Manor or Thomas Hardy, or people who are watching at home or on the recording, we certainly encourage you, you know, to ask your questions about science and maths and technology. One way is you can, you know, actually apply to the Google Science Fair. If you've got a project you've been working on at school, we encourage you to certainly have a go and apply. You can visit google.com/science fair, and you have until April 1st to submit your entry. It's the world's largest online science competition, and you can enter in 13 languages. So hopefully one of those will work for you. And what about if people want to learn more about Festival of the Spoken Nerd, the group who joined us today? Well, they can visit festivalofthespokennerd.com. And Helen, do you have any more shows coming up at any of the other festivals or anything, or shall people just go to the website to find more?
Yeah, it's best to go to the website because we are doing Cambridge Science Festival, which is now sold out. We're doing Edinburgh Science Festival, but that is for 18 plus only, so your teachers can go. You can't. But we'll be doing other shows, and we have a podcast which cuts up some of our shows you can listen to. But I think, yeah, something that's really...
all the information on the website for the podcast as well. And you can follow us on Twitter, and you can go to our Google Plus page and all that stuff.
Yeah.
Excellent.
I think the thing we really love doing is not having to leave science in a little bubble on its own, and that's what we try and do. We mix science and comedy. I mix music and science. Science doesn't have to be just for your science lessons, and nothing else in your life can get involved. Science is everywhere. You can mix it with all the other things that you do, with sport, with music, with cookery classes.
Maths.
It doesn't matter. You can mix all of those things up, and those are the interesting questions that I find. Or when science starts to invade parts of your life.
Thank you so much. And thank you to Thomas Hardy School who joined us. We really appreciate it. And also, thank you. And to Plumstead Manor School for Girls, thank you so much for joining us. And that's a wrap. Everybody have a great day. Happy National Science and Engineering Week for those of you in the UK. But we're celebrating it all around the world, really. And I hope everybody has a great weekend and has a great maths party tonight. Bye.
Bye. Bye.
Bye.
Bye.
Bye.